Let's talk about balancing chemical reactions. Now, whenever I tell people what I do, one of the first things they say to me is, ugh, I could never balance chemical reactions. So let's break it down and make it a simple process. When you have a chemical reaction, it's made up of certain things. So the reactants are the compounds that are going to be reacting with each other in order to make something. So reactants are always going to be on the left side of the arrow. In this example of a chemical reaction right here, the reactants are on the left side of the arrow. So the arrow is going to be what separates the reactants from what they are making. Now, let's talk about what it is they're making. They are making the products. So the products are the compounds that are formed as a result of the chemical reaction. They are the product of the chemical reaction. And the products are always given on the right of the arrow. Now, this reaction arrow here can also be read as yields. So the reactants yield the products. Chemical reactions are used at crime scenes or in a lab to identify evidence, such as to screen for the presence of illegal drugs. A positive result produces colorful compounds indicating the presence of illegal drugs. They can also be used um, to make different things. So, in a chemical reaction, the law of conservation of mass is observed. So, for that reason, the reactants and the products within the chemical equation must have the same number of each type of atom. Now, to balance a chemical equation, we add coefficients in front of each compound. So the first thing you want to do is list each type of atom in both the reactants and the products. I also like to make sure that the order I list them on my reactant side is the same as the product side. Now you have to identify how many of these they have. So if I look at my reactant side, I have two of my AS. So I can write a 2 next to my AS. Now for carbon, I only have one carbon, and for oxygen, I have a subscript of 3, so I have 3 oxygens. Now I'm going to do the exact same thing on the other side. I have one AS, one carbon, and one oxygen. So hopefully you can see here that this reaction is not balanced. And since the law of conservation of mass is observed, then we have to make sure to balance them. Now, I can start with my AS. And I'm going to balance these by adding coefficients in front of each compound or element. So I can add a coefficient of 2 to the AS in the products. Now, when I do that, notice that it changes my count to 2. Now my AS is balanced. The next thing I'm going to look at is the oxygen. So I have 3 oxygens on my reactant side, but only one in on my product side. So I'm going to add a coefficient of 3 in front of my compound. Notice I cannot put the 3 right here because if I do that, I'm dealing with CO3, which changes the identity. I don't want to change the identity. I just want to change the amount. So to do that, I have to put a 3 out in front. Now, when I do that, it's going to change the amount of oxygen, but notice it also changed the amount of carbon. So by balancing my oxygen out, I now have created a problem for carbon. I'm going to have to go and balance the carbon out. So to do that, I would put a 3 in front of the carbon on my reactant side. Notice when we did that, it all balances out. Now, when you are balancing these chemical reactions, you really want to have a strategy. So, the first strategy I'm going to talk about is you want to balance the things that appear as only one reactant or one product first. So, for example, notice that oxygen is present in both of my products. So I want to leave that one until last. I want to look at my carbon and hydrogen because those two are only present in one thing. So I can write out my elements first. So I have carbon, hydrogen, and oxygen. And I'm going to do the exact same thing over here. So to start out, I have 1 carbon, 4 hydrogen, 2 oxygen. When I end this reaction, I have 1 carbon, 2 hydrogen, and 3 oxygen. So I notice that the carbon is already balanced out. I don't want to start with the oxygen because I want to balance the things that appear in only one reactant and one product first. So I'm going to go with my hydrogen. So to balance out my hydrogen, I'm going to put a 2 in front of my water. And by doing that, I change my hydrogen count to 4. Now, when I did that, I also changed my oxygen count to 4. I have 2 from my carbon dioxide and a total of 2 from my water. Remember, when I have 2 water, it's also like writing it out like this. I have 2 waters. So here I can see that I have 2 oxygens present and 4 hydrogens. So now I can go and balance my oxygen. I need to make a total of 4 oxygen on my reactant side, so I can put a 2 in front of my O2 gas. And in doing that, I now have a total of 4 oxygen, and my entire equation is balanced. The next strategy is to keep your polyatomic ions together. Now, this is very important if they are unchanged in the chemical reaction. This will save you a lot of time because you'll notice in our polyatomic ions, we deal with a lot of oxygens. So when I go through and identify what is present, I'm going to say there are 2 potassium, but instead of saying sulfur and oxygen, I notice that I have sulfate on this side of the reaction, and I have sulfate on this side of the reaction. So I'm going to keep that together. I have SO4 here, and I only have 1 of them. The reason I know there's only 1 of them and not 4 is because that 4 is part of the sulfate. If there was more than 1 sulfate, then it would have parentheses and a number outside indicating how many of the sulfate I have. Now, my next atom is barium. So I can write barium down. I only have 1 of them. And then I notice I'm dealing with another polyatomic ion, hydroxide. So I can look on the other side of my reaction. Oh, there is OH again. So I can keep my hydroxide together as well. Now here, I have parentheses around my oxygen or my hydroxide, and there's 2. on the outside of the parentheses. So I have 2 hydroxides. So now I'm going to do the exact same thing on the other side, and I want to keep my order the exact same so I can make a linear comparison. So on my product side, I have 1 potassium, 1 sulfate, 1 barium, and 1 hydroxide. So to start off with, I'm just going to start with my potassium, because here I can look at my first thing and I notice that it is not balanced. So how can I balance out my potassium? You got it. I'm going to put a 2 in front of my potassium hydroxide. And when I do that, I change my potassium count to 2. Well, what else did I change? I also changed my hydroxide to 2. And what happened? You got it. It balanced the reaction out. So sometimes when you balance one atom out, you end up balancing the other thing out as well. The third thing that you want to do, the third strategy, if you will, is balance everything and save the elements for last. And that's because they're easy to manipulate. So in this example, you might be thinking, oh, but there's no elements by themselves. Remember, oxygen is a diatomic element. So I can write out everything present. NH3 is not a polyatomic ion, so I'm going to break it up. And I have 1 nitrogen, 3 hydrogen, and 2 oxygen. Now I'm going to do the same thing on the other side and keep it in the exact same order so I can make that linear comparison. I have 1 nitrogen, 2 hydrogen, and 2 oxygen. So when I look at my strategy for balancing this, I don't want to start with nitrogen because it's already balanced. And I can either start with hydrogen or oxygen. Now, hydrogen only exists in compounds. Oxygen exists by itself as a diatomic element. So I'm going to balance the hydrogen first because my oxygen is going to be easier to manipulate. Now, I notice that I have an odd number of hydrogen on my reactant side and an even number of hydrogen on my product side. So I'm going to double the number of hydrogen on my reactant side so that I can get an even, sorry, I said double, but then wrote 3. There we go, that's double. So I can get an even number of hydrogen on my reactant side. So now I have 6 hydrogen here, but that also messed with the number of nitrogen. I now have 2. So in order to balance the hydrogen on the other side of my reaction, I also want to make 6. So I can put a 3 in front of my hydrogen, and that will give me 6 total hydrogen. Now, I put a 3 in front of the hydrogen, but really I'm putting a 3 in front of the entire molecule water. So I have 6 hydrogens, but now that changes my oxygen count to a total of 4 because I have 3 oxygens from my water and 1 oxygen from my nitrogen oxide. Now, as you can see, we messed with the number of nitrogens. So I'm going to have to go through and balance my nitrogen. In order to do that, I'm going to put a 2 in front of the NO on my product side. And when I do that, I change my nitrogen count to 2. And now my oxygen count has also changed. So how many oxygens do I have now? Yep, we now have 5 oxygens. So in order to balance this out, since I have O2, I can't do a 2 right here because that would only give me 4. I can't do a 3 right here because that would give me 6. So what I'm going to have to do is I can do 2.5. And that changes my oxygen count to 5. And we now have a balanced chemical reaction. Now, if your reaction requires only whole numbers, then in this case, you can double all of your coefficients. So this would be 4, 5, 6, 4. So if you ever get to the case where you have a half of a mole or a half of a coefficient, then you can just double your entire reaction to get the whole numbers. So here are some balancing problems that you can practice with. Go ahead and do these problems. If you are stuck or you need help, you can always email me to see if you have done them correctly.